Hello. This time we're going to talk about the relatives of the conditional statement. So, to begin with, let me start like this. A conditional statement has symbolically the form P implies Q, right? To be read in common natural language, if P then Q, also as P implies Q, right? But now that we have these symbols, right, we can just essentially reverse the order of implication, right? Reverse the arrow, and we get along this the converse. We have its converse. What would that look like symbolically? Well, as Q implies P. Now, also, its inverse, which would be by introducing negations on each of the components of the implication, both the antecedent and the consequent. How would it look like symbolically? Well, as not P implies not Q. And the contrapositive. All of them referring to the original conditional statement. Symbolically, not Q implies not P. Now, something to notice here. Know that the contrapositive is the inverse of the converse. If this helps us remember things. Now, how is it these four possible, let's say, implications are logically connected? Well, let's study those through a truth table. Right? Well, let's see. In this case, we can make it with a truth table. P, Q, and now, of course, we have all the possible interpretations associated with two statements. That would be true, 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 false, false, true, false, false. And now, well, I'm going to indicate all the ones that we just wrote, the four implications. P implies Q. Now, its converse, Q implies P. Its inverse, not P implies not Q. And lastly, the contrapositive, not Q implies not P. Okay. Now, when is that an implication evaluates to false? Well, it only evaluates to false when the consequent is false, while the antecedent is true. Well, meaning that we should have the following configuration. It should be false here and true everywhere else. But if we follow those lines, we would have that the only possibility for the converse to be false is exactly under this interpretation, the one that I'm signaling here. And, well, that would be true for everywhere else. Now, what about the inverse? Well, for the inverse, well, it would be exactly the same case. It would be just here that it evaluates to false, and everywhere else it would evaluate to true. What about the contrapositive? Well, the contrapositive would evaluate to false when the negation of P is false, while the negation of Q is true. But that happens exactly under this interpretation, so that would be false here and true everywhere else. Well, now that we observe this, well, we see that now these two are logically equivalent, but also these two. What does this mean? Well, that means that whenever we want to, for example, demonstrate that an implication is the case, we can also demonstrate that its contrapositive is the case. Or when we want to demonstrate that the converse is the case, you may demonstrate that the inverse is the case. Right? Whichever one looks a little bit easier to demonstrate. And with this we conclude. I'll see you next time.